Hi, my name is Shrey. I am one of the Jira developer productivity leads inside of the Jira Scale Foundations org. So a lot of random words. I'm sorry. This slide deck and this presentation I gave to a bunch of engineering individual contributors and managers at our internal conference called EngFest about a week ago. It basically tells the story of how we built, maintain, and use a bunch of tools inside of our main monorepo, the Atlassian Frontend monorepo, to transform and automate the code mod of a shit ton of work. Atlassian Frontend monorepo has around 400,000 files and a lot of extra pieces of code. And so let's go through what we did, how it works, and sort of some lessons you can take away for that as well. Great. So agenda. I've got 30 minutes. I'm going to be yelled at if I take longer than that. So I will try to speak not super fast. How do we get here? If you haven't used Jira before, get excited. You're about to learn about it. So lots of people ever. We're going to talk about the scale paradox, right? Which is like, oh, there's lots of code, lots of engineers. Surely it's easy to do these sort of transformations, right? You just tell the engineers to do the work. We're going to talk about static analysis, how we used it. We're going to talk about the elephant in the room, which is like, why even bother? Can't AI just magically do the things you need to do? We'll talk about some real world examples that we currently use this tooling for today, and we'll move on from there. So over the last couple of months / quarters, my org has been working through this initiative we like to call Thunderstone. It takes after a previous initiative from the Jira backend org, Jira backend obviously being the backend for Jira, which is called Thunderstone. Now, Thunderstone talks about basically separating and cleaning up Jira's module graph. So what is Jira? Jira can't be that complex, right? Jira, how many routes do we reckon Jira has in the front end, right? Like if you haven't used Jira before, you got like, oh, you can view the work item you're looking at, right? You can view maybe a board, maybe a backlog, maybe what, 20, maybe we'll round it up, 50, 100. There's actually over 800 routes in Jira frontend. And over the course of Thunderstone, our goal has basically been to take the 20 plus years of development of Jira, and a lot of that being the front end, and actually restructure the entire code base without causing a single incident. And that's fucking hard. Also, am I allowed to swear? I come from Atlassian where we swear a lot. Cool. That's hard, okay? To do all that without a single typo, without a single missing reference, without a single incorrect rename, really hard. Also, we do this at the same time as hundreds of engineers are making changes all the time. So how do we do it without breaking any of their changes? Really tricky. This talk is not about tech debt. This slide was aimed at all the people who were scared I was trying to convince them to invest more in tech debt. As every manager knows, every engineer just wants to make the code base look prettier, right? Like, isn't that what we want? No, it's not about that. It's actually about scaling our ability to ship stuff to customers. We have a problem in Jira. This is a graph of lines of code in Jira frontend. And you can see the lines of code roughly doubles every 2 years, which should be scary for those who are engineers. This is where we're at today. So this graph is actually a bit old, and it's once again picked up to around 14.5 million lines of code. You'll see this graph later on as well in a different talk. But there's a lot of stuff here, right? There's a lot of code. It's scaled over time. We've gone from what used to be literally pieces on Java monolith web apps given to you on a floppy disk to different companies to a fully cloud-based system with at least like 6 different products in the front end, right? There's a lot of code. As an example of that, oh no, that's weird. Oh well. As an example of this is a picture of some vibe-coded slop that I put together that takes the dependency graph of a core package called IssueViewBase. IssueViewBase is basically the composer of the issue view, right? It's like, here's the issue view. Tell me what fields I should put on the side. Tell me like what the description should look like. Plug in all these things. Now you'd expect if I described that to you that this IssueViewBase package would be very thin amount of dependencies and not used too much, right? Well, this is what it looks like. It's a complete opposite of what you would expect it to look like. And sort of part of the goal of Thunderstone is to understand why the hell does IssueViewBase have 680 dependencies? Because we didn't know either. This is not a process that you can automate, that you can do manually, right? This is one package. we have around 6,000, 5,000-ish packages inside Jira Frontend. So this is one, and it's 680. Now multiply that by the amount of code that we have, right? So it's not a piece of work that we can do. The reason this is important, is because every time you run a test, every time you type check has to do, every time you open your IDE, all these tools start processing all these little dependencies, right? And that's the same for all of your dependents as well. So yeah, it makes you feel like this as a developer a lot of the time. We've done a lot of initiatives to work through speeding up different tools, right? Oh, just use TypeScript Go, that'll fix everything. Or like just use this new tool here, like Oxlint or build systems or blah, blah, blah. But at the end of the day, those are all wrappers around the core problem, which is all of our code talks to every other piece of code. That's sort of what happens when you compound 20 plus years of engineering into a bunch of React. To really illustrate this problem, we went and did some numbers. We had this number we made up called complexity. Complexity being for a given package, what is the multiplication of the number of dependencies times the number of dependents, right? So how interconnected is that package? And we went and calculated that number for some of the biggest products we have. So you've got Platform, which is like our internal Atlas Kit design system, think your buttons, your layouts, all sorts of stuff. You've got Confluence, which is another one of our major products. You've got Post Office, and then that red one over there is Jira. So it's not just a scale problem. It's not just a large product problem. It's something unique to how Jira was built at the time over the course of those 20 years that has caused this to be the case. And so why is it important is we want to ship a lot of stuff to customers, right? We want to do this work. But if every engineer out of the, I think, 1,200-ish PRs that land a week into Jira, if every engineer is losing hours of time to CI builds, to local development, to testing workflows, even if you think beyond in terms of AI and agentic workflows, if they can't even work because they can't even run a type check locally, then we're like wasting a huge amount of time. So this is more than just tech debt. This is a huge problem that we have to address. So when we start talking about this a couple of years ago, one of the questions that gets asked is like, okay, that's fine. Just ask every team to refactor their code. Simple, right? Just send them all a thing saying, you're all going to refactor your code, make it all nice and composable and design patterns and think back to your design pattern days. Turns out you can't just do that. It takes a lot of coordination. And even doing that, we need to make sure we have guidelines and tools. Why don't we just do it for them? Can we do that? Right? Like maybe? So this is a nice slide that I sort of found somewhere, which talks about sort of that scale paradox where everyone's like, if you've got a lot of people, you've got a lot of things to do, surely you can just coordinate that outwards. Anybody who's done that sort of coordination across a bunch of teams, you end up realizing there's actually an overhead to coordination, right? All those teams you've asked to do something come back to you and say, hey, what about this scenario? What do I do here? Or, hey, that tool you gave us doesn't work anymore. Or, actually, we can't do this in this timeline. Can we have an extra 6 months? We can't do this timeline. Can we have an extra 4 years? Maybe we'll get to it then. Actually, our last manager agreed to this. We have no clue about this. We're not doing this anymore. There's a lot of change cost that can happen. And that's even before we get to the technical side. Merge conflicts, technical drift, like understanding the relationships, teams need to talk to each other, understand. Do you need to inform your dependencies or dependents, etc. So you end up getting to a point which is that frozen architecture zone. It's like if you get to something that's that challenging, then somebody talks about it. It's like, no, absolutely not. Later today, you'll hear about one of those examples, which was we migrated our test suites from one framework to another, which is very scary to hear about. It's like, hey, can I just rewrite every test in the entire front end to this new thing? Hard to do. And so you end up with this effect where there's a bunch of like things that make this initiative challenging, right? So linear growth fallacy, I talked about verification tax. I've already explained how this is a problem, but now I have to actually migrate millions of lines of code and then wait 2 hours of CI before anybody else changes it and so on. The feedback loop, right? Eventually, as things scale, the tools fail too. We have a lot of internal like forks and adapters of tools that are forced to work on the scale that we have because of traditional tools sort of don't hit the it's hard to explain. We have like certain forks that operate with the assumptions of our codebase in mind, I guess. And eventually they just fall under load. So why invest in a platform over one-off solutions? Why not just say, all right, let's do a project to make this faster, or a project to make that faster, or make the PR time lower? And so this is where we got into static analysis. So the Atlassian front-end monorepo has been around for a little while now. It is the house of pretty much every piece of front end of every major product in Atlassian, which has real benefits for us because it means that we can build tools that can just read all the code at once. So the monorepo has around 500,000 files at the moment, and of that, around 100,000 files-ish are Jira, rough numbers. And so we built a tool that can basically, we built on top of a tool that we have that can take any given TypeScript file, what the time is it? 6:47:30. Yeah, cool. Take any given TypeScript file and extract what we call facts from that. So here is some diagram of that where it's like there are tools out there, which I'll talk about later, that can take all the imports, the exports, sort of the type signatures, anything of use, anything that we care about, and extract every single file, even though they're megabytes and megabytes and megabytes, down to a couple kilobytes of core important facts, right? When you do this for every single file in the monorepo, you'd expect that to be slow, right? Every single file needs to be open, read, close. And if you have done a bunch of systems programming, that's 3 syscalls times 400,000 files, 1.2 million syscalls on your computer. It's not going to be fun. But you can get around that, and you can use things like you can use things like content addressable caches and say, well, I know that since the last time a cache was generated, only these files have changed, only extract those files, etc. But only extract them if something has changed properly that I care about, not just a random like date. And so we use this, and we effectively have this system, which we call FactsMap internally, that can scan the code base and get us this data. Now, with this data, we can create APIs and bindings and plug them in to common tools in the industry like JS CodeShift, FastMod, Open Rewrite, all those tools you've heard a bunch about, as effectively inputs and outputs, right? So we can say, for example, all right, we found every piece of code in the code base that imports React, right? And then do something with that. So one of the things we did, for example, was enforce that all files are meaningfully named. When Jira's conventions were made in 2015, 2014, some of the first React front end we had, everyone decided it'd be a great idea to name everything index.tsx, which was great at the time when there was only a couple of pieces and one screen in the modern day front end. Everything else was in the Java world. But as you scale to 100,000 files, 80,000 of them called index.tsx is not fun to work with. And beyond the fun part, it also helps us to understand those dependency couplings and so on. We use the Oxy toolchain for this. So we have custom Rust tools. We like Rust at Atlassian. We use it where it makes sense, where we have the traditional tools fail us. And using that, we're able to effectively open and parse every single file in the monorepo in about 15 seconds, which is pretty neat because that's with no cache at all. When you have a cache, you can now get that down to only a couple of seconds, and now your pre-commit hooks can do this sort of stuff for you, right? Your CI checks can do this stuff for you without waiting several hours and so on. Great project, lots of tools that they've built themselves, but they've also open sourced all their libraries, which we can use on top of that. So a parser, a transformer, etc. So this is sort of a similar diagram with the cache stuff. So we have like cache, and you can do all this smart, nice things to make sure that you're doing as little work as possible. Don't repeat work you've already done, right? Make an incremental cache, effectively build our own mini build system, but for the entire purpose of getting information that we can then use in codemods and tools. So I talked about this example earlier. Effectively, what we did is you can basically write tools that take that information and then start to walk through it. So from the top of the Jira issue view base, now we have the facts of every single dependency. You can just write like a DFS to find a target dependency, and you start to get back into graph theory and algorithms to figure out like, okay, where is the most longest chain? Where is the shortest chain? What are the most common chains that exist? Oh shit, 30 different people are importing this library for the singular constant called like issue in a string. Why? And you'll hear about that more later on as well. But you can start to analyze this data and do stuff with that data. At this point in time, you start to realize at this scale of code, we're not just talking about coding problems anymore. We're talking about algorithmic problems before. The exact same problems a bundler has to deal with when you're deploying this sort of code, right? Is like find all the bundles, compress it, dead code elimination, and so on. It's about performance. What bytes are we shipping to users? We have tools that is built on top of the FactsMap system that can tell you for a given PR change what has changed and what bytes have changed, and therefore like highlight any performance regressions. Like, oh, you accidentally introduced a YouTube video in every single page load. Maybe you shouldn't do that because that's a performance problem, right? And so this FactsMap tool gets used across a bunch of different systems. And we're not alone in this. Like, I think every large company that we've talked to and talked closely with have similar versions of this all around different systems. So there's like Glean. We've heard about. You've heard SourceGraph, which is a common tool for searching multiple code bases. Have their own indexing protocol called SCIP or SCIP. This is not a new problem, right? But we started to hit it and we started to solve it in the way that we've done. So the question we get is like, can't AI solve this? I'm running against time. No, yes, sort of. I asked one of our internal tooling, one of our internal AI systems and a few other open source AI systems, how do I run a unit test in Jira Frontend? That was the response it gave me. It couldn't figure it out. And yes, obviously, part of that can be solved with proper context and instructions and blah, 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 right? But that you can't add context and problems for, and context and skills and MCPs for every single thing you want to solve. At the end of the day, you need to have a slice to avoid context rot, right? Context is how LLMs operate. Everything you give into it and everything it gives to you back is part of the context that it will use to inform the next response. So if it then has to look through 100,000 files because it can't figure out the dependency chain, and it then looks through all 680 of those dependencies, that means that it's now lost a shit ton of its context just to figure out where your code is used. Only then can it give you the change you want to make, which means we have inaccuracies, we have problems, and it's also slow and also expensive. Looking at some data recently for some of our internal stuff, I keep running into context limits and token limits because I spend so much trying to do some of this work by saying things like this, which is tell me every single place this package is used. And it gave up. It said this, too many matches found. I can't give you the answer, which is sort of backwards to what we want to be able to do with these tools, right? We want to be able to give a task to our agents and say, here's a task, can you go and add this thing to the context service or do this thing with the context service, blah, 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 without it sort of falling on its knees and saying, sorry, I just can't. And so I had some diagrams here around, everyone keeps figuring out different names for this, right? Like we're going to call it prompt engineering, we're going to call it context engineering, we're going to call it building a code agent, we're going to call it memory, we're going to call it sub-agents, MCP, all these new fancy things. But at the end of the day, if your code base is still a mess, it's still going to run into those problems. So I stole this slide famously from one of the AI engineering talks, which talks about sort of the smart zone and the dumb zone, which is like you have all the stuff you inject in your repo, which is like your context, your like your agents.md, your MCPs, blah, blah, blah. And it's like, great, I have all the context, let me do the work. But in this case, for Jira, the context is huge because there's a lot of code. And so the smart zone gets really, really small. So people are trying to solve this in different ways, which is like, okay, well, let's use sub-agents and let's use all these tricks to like compress as much information as possible. And yeah, that's totally feasible to do. And here's another example of when I asked it for how to run a test. 200,000 tokens used, not very smart was the answer. So these models can't be computing systems. At the end of the day, when I'm doing refactoring across millions of lines of code, I can't afford a mistake. I can't afford a, oops, sorry, I missed that dependency, and now the issue view is crashing in production. And so I asked it again, another trick for the slides of like, hey, tell me where it's used, and it gave me an answer, but it was wrong. It completely missed a whole bunch of places it was used because it just gave up and started hallucinating. So when we used our FaxMap tools, we've got a bunch of Rust CLIs built on top of FaxMap. It does like some really powerful like graph analysis for a bunch of like find me the most coupled areas so we can start tackling them independently. It gave me the answer within a couple of seconds, not what was previously like 30 minutes and then token limits and all sorts of stuff. Couple of seconds, you can use your tools and someone's like, oh, we can make an MCP for this and do skills and stuff. It's like, no, it's just bash. Just call a thing and get it to get some data back to you. And it was totally fine. So here's where we're at today. We use FaxMap for all these things. We've landed, I had a bunch of screenshots, but they contained a bunch of stuff I probably shouldn't be showing. But we use these tools to find, first of all, dead code in the code base. So you've heard of tools maybe in JavaScript like nip. Nip is great. It's incredible. I encourage you to use it if you haven't already. It falls over on Jira. We've tried a bunch of stuff. We've worked with the team to help some of that, but at the end of the day, it struggles. So we use FaxMap on top of that to find all exports, then find a reverse map of every export and tell me every file it's actually never referenced anywhere. Great, delete it. And so we've automated like PRs that will delete it. We have mutation testing that again uses FaxMap to find all affected tests for a given change. We use developer tools as well to run those affected tests locally by finding the dependency graph for your given change, what tools have run. Some test runners do include that natively, which is great, but again, they all fall over. I think we use Jest to run our tests in Jira Frontend. When you use Jest like run affected, it will take up to 40 minutes to find all the affected tests for one file change, whereas FactSnap can do it in a couple of seconds, which is great. We have Jargon. We have some other tools that use it for kicking off builds faster. So when you push a change to the monorepo, which builds do you trigger? Right? You have to do some affected things. Should I trigger all Confluence tests? It's like, no, I only change a thing in Jira. Why would I bother running Confluence tests? All that sort of stuff. And we use it for a bunch of debarreling efforts as well. So on our Atlassian blog post, we've got a whole thing about how we debarrel the entire Jira frontend. So no barrel file indexes, no index.tsxs that are barrel files specifically, because they were hurting a bunch of our performance. We use it for updating TypeScript project references on a schedule automatically, right? Inspect the dependency graph and just automatically add a PR when that dependency graph changes for TypeScript to know who's calling what. We made another vibe slop website of like, what if you could just do SQL on that data and like select all blah where this is used and do that sort of stuff. You add another vibe slop website around that data again, around the dependency graph. This is the dependency graph of a modal randomly somewhere in Jira. And if you're wondering why the fuck does a modal have so many dependencies, great question, so are we. We're trying to figure that one out and cutting down some of those links. And we renamed every single file in Jira's issue view without causing a single problem. And that was sort of one of the coolest things we've done. I think 25,000 files completely changed, completely rewritten. Not a single customer ever really noticed. Any of the incidents weren't us, I swear. And I think that's really impressive. We're very happy with that. We're going to keep working towards it. We're getting some of those. The goal is that every single developer tool should be O of changes, not O of the code base. And that's really hard to get through when you're cutting through 15 years, 20 years of crap. So yeah, that's my talk. Using static analysis to power DevProd. It's a very hard and fun job. If you're interested to learn more about it, come chat to me afterwards. I'm literally on the dot, half an hour now-ish. Thank you. Yeah, I don't know what time to get.
Yeah, does anyone have any questions for Shrey? Yeah, awesome.
I've never worked in a team as big as Atlassian. Usually I work in teams of maybe 4 or 5 engineers. But even then, if you do any significant change to the code base, you annoy everyone else because you break all their in-flight PRs or branches. So I'm just trying to imagine, like, when you do these sort of large global changes, like those 25 files renamed, how do you sort of not break Atlassian for a week with everyone getting a 1200 merge complex? I never had 12 PRs.
It's definitely taken us time to get there. I think it definitely does break a lot of team stuff, but it's more of a cultural thing of these are core infrastructure things that need to happen. And you'll never, ever be able to make everyone happy. We have a concept of maintenance windows where we shut down the merge queue and we say for the next 3 hours, no one can merge. And we try to announce them like a week or 2 in advance to say, hey, FYI, this is going to happen. Land your change before then, otherwise sucks for you. Like you're going to have to rebase and deal with the conflicts later. Like, unfortunately, it's really hard to schedule around 1,200 engineers and figure out who wants who. We do occasionally try to schedule something and someone's like, hey, can we just push it a week, please? Because we have this really important XYZ. But yeah, communicating at scale is really hard. I had a different interest talk around that, which is like, how do we communicate these changes? Even just the like developer standards and stuff of like, hey, where did my files go? Like, oh, they used to be here, now they're over there. What's going on? Or why did you break this import? It was really important to us, blah, blah, blah. Developer education is a really hard job. You can have the best intents, do as much work as you want, and people still might not listen. And that's where it comes down to pushing that left into the IDE, into your tooling, into your pre-commits, warnings, announcements as much as possible. It's tricky.
So you can't you've got no way of statically adjusting in-flight branches.
We could, but I feel like we've historically avoided that because engineers don't like when we touch their code. If you've got someone's PR and like you see an automatic code come through, it often leads to more questions and frustrations than it does like happiness. Yeah. We've tried it in past.
Anybody else? Oh, yeah.
Hi, great talk. So thanks for sharing that. The question I have, though, you say the code base was about 20 years old, and not every 20-year-old code base get to this level or that bad. So what could Atlassian have done before you get there to actually stop it from getting there?
I think that's what we're trying to figure out today, because I'm giving this talk now, but my job now is to make sure it doesn't get that way in 20 years' time. Because it's all great and fun for someone to say, we did it, success, great, but there's no guardrails. And then 2 years later, it's gone back to where it started, which is what's happened historically in this domain, because everyone's like, I'm going to make this tool faster, and then it regresses. So we're putting in, like, we've got a bunch of rules that use FaxMap as a base to figure out, like, there's common patterns in open source, like architecture violations, right? Like your big packages should never import your small packages never import big packages. Cultural uplift with like education. I think fixing it 20 years ago, if I told someone 20 years ago that Jira Frontend we had 14 million lines of code, they would have sent me home. Like there's no way, it can't be that bad. But yeah, that's what we're trying to figure out today with a lot of like tooling that can shift again that education piece left, show developers the cost of their imports. Not every string or const or type import is treated equally. We have a big problem, and there's going to be another talk about that in a second around not just us, but just in general, bad habits that we're trying to break.
All right, anyone else? Yeah.
Through this process, do you ever had to deal with circular imports?
Yes and no. We use TypeScript project references for our like packages, which is a system that allows you to define projects like as a group of files for TypeScript to check, I guess. One of the hacks you can do with that is sort of bypass circular references by saying this subset and this subset should never import each other. They're different projects, but we've just tried to delete as many as possible. Like circular file references and circular package references, we can work around them for as much as we want, but at the end of the day, they're always going to be there and they always cause problem. So we've actually just finished a couple of projects that have removed, I think, 1,500 different circular project references from the code base that are really hard to unwind. So yes, we encounter them a lot, but I think historically for the last several years, people just avoided them, work around them. But at the end of the day, they still are consumed by tools. They still are consumed by dev loops, by AI agents, by everything. So we've finally tried to bite the bullet and get rid of as much as we possibly can, and also stop them from reoccurring. So we've now got rules in CI and local that say if you introduce a new circular reference, it's just blocked. You can't do it. It's really hard. Cool.
All right, one more.
I want to ask a question regarding like the flag extraction. Like, do you have to do like flag extraction for each file, or like you group like a project level?
Every file.
Every file?
Yeah.
And then so
we have some that are excluded because it's just like generated JSON mock garbage, but every source file, yeah.
Wouldn't that take like a very long time? Like
10 seconds.
Oh, okay.
Yeah.
Because I was considering like group, like project level folders and then extract from that kind of project folders.
But we just don't really have a need to. So we can do it. We can do the whole thing in 10, 15 seconds, depending on your hardware. And native code nowadays with like with like SIMD and with like parallel computing and with like native tools like Rust and Go can do stuff really fast. And I think like the web ecosystem is slowly starting to realize that, which is why more and more tools are being built in those native things. And so we use the native Rust bindings from the Oxy project for a bunch of our tools. And if we need to do something really big, we'll just put it on a cloud box somewhere with a shit ton of CPU and say, all right, go do that. But no, most of the time, we also have a cache, so you also never need to do a full extraction, but a full extraction is like 15 seconds-ish.
Yeah. Thank you.
All right, can we have another big round of applause for Shrey?